In this video we are going to discuss about the analog to digital converters. So on completion of this topic, students will be able to explain the ideal characteristics of the analog converters. So analog to digital converter is nothing but ADC that allow the microprocessor control circuits, that is Arduinos, Raspberry Pis and other digital logic circuits to communicate with the real world. So in real world, analog signals have continuously changing values with some various sources and sensors that can measure the sound, light, temperature or movement, and many digital systems that we are interacting with the environment by measuring the analog signals from such transducers. So here are the two types of the converters. One is digital to analog, analog to digital. In the case of digital to analog, the output of the analog voltage is the proportion of the reference voltage and the proportion based on the digital world applied. In the case of analog to digital converter, the digital representation of the analog voltage is applied to the analog digital circuits, that is it can be a representation of the reference voltage. So the major factor of this function is this will have the high input impedance, and if the low input impedance is set, then there should be an external stress. So while analog signals can be continuous and it can provide a infinite number in different voltage values, so this digital circuits on the other hand, this can be high or low, that can be logic 1 or logic 0. So it is necessary to have an electronic circuit which can convert between the two different domains of continuously changing analog signals and discrete digital signals. So basically an analog to digital converter takes the snapshot of analog voltage at one instant, and it provides the digital output code which represents the analog voltage. So this can be used to represent the analog voltage, that is depending on the resolution of the A to D converter. So you can see the advantage and disadvantage. It is simply fast, inherently monotonic and compatible, and the disadvantage is 2 power 8 resistors and 2 power 8 switches for B bits are needed, and high setting timers B greater than 10. And the binary weighted digital to analog converter is basics, in which the input current will be proportional to the binary value, and basically this analog to digital converter takes the major thing of resolution in the form of 2 power 4 minus 1, and this has the wider terminal in the basic potentiometer, which is mainly replaced by the single rotatory switch, and it is connected to each junction of the series resistor chain. And you can see the example of this one. So if you are giving the certain amount of current towards the voltage for the digital circuit, this potentiometer will be widely replaced by the single rotatory, and this forms the basic potential divider in the circuit. So as the switch is rotating from one position to the next output voltage, this can be quickly changes in discrete as well as in the distinguished voltage setters. So this can be used in 2 volts, 3 volts, 5 volts. Also it can be used in the 2.5, 3.1 and 4.6. And auto or ladder is the process which we are using here for converting the equivalent digital current can be done in various ways, and also this will be having the analog to digital chips, such as each series should be available from the various manufacturers. So one simple and easiest way is by using the parallel encoding, and this can be used in the flashes, simultaneous or multiple comparator. And the major advantage is that they are very simple to construct, and also they do not require any other timing clocks for their instant applications, or this can be compared with the reference voltages. So here also an example for the ladder. So possible questions on A to D converters. Can you give some examples of the real world application that use A to D converters?